Hey everybody, let's actually get into the nuts and bolts of drawing Lewis dot structures here. Now, whenever we're drawing Lewis dot structures, there are 5 steps that will always get you um, the right Lewis dot structure. Okay, and these are the 5 steps. I would take a minute, pause the video, I would write them down. And then what I'm going to do is, after you write these down, I'm going to go over some sample problems. And based on the sample problems, I will go through the steps. So that way you can see the steps and know what's going on with them. So, phosphorus trichloride. The first thing, we have a name here. So with the name, we may want to write the formula. So that's PCl3. Okay, so the first step is to count valence electrons. Phosphorus, okay, and I will do that here. Phosphorus is here. It has 5 valence electrons, so that's 5, and chlorine has 7. Okay, I know that because of the second number in the group there. Okay, so phosphorus has 5 electrons, and chlorine has 7, and there's 3 of them, so that's 21. Okay, so that's a total of 26 electrons. Now that number of electrons is how many electrons we're going to place around the Lewis structure in total. We can't have any more or less than 26 electrons, so we need to make sure at the end that's how many we have. Okay, this is the number one reason why people mess up Lewis structures, is because they forget that there has to be the correct number of electrons in the structure. Okay, so now the second thing to do is to draw a what we call a skeleton structure. Okay, so the skeleton structure is pretty neat, because what happens is the least electronegative element, which is usually listed first, okay, goes in the middle. And so we're going to put a P there. And then coming out on all the sides, we're going to put the exterior atoms, okay? And that's what those are. So the least electronegative element goes in the middle. The only exception to that is hydrogen. Hydrogen, because it only wants 2 electrons, can only form 1 bond. And so because hydrogen can only form 1 bond, hydrogen can never be a central atom. So just some terminology, this guy is the central atom, and the chlorines are the exterior atoms. Now, for each of these atoms, let me just tell you that the line represents a covalent bond. That covalent bond has 2 electrons in it. So if we're going to count electrons, which we already have, there's 26 here, how many have we placed? Well, each line here represents 2 electrons. So that has 2, 4, 6. So already it has 6 electrons used. So now we have 20 more electrons to do something with. Okay, now the third step in determining Lewis dot structures is to complete the octet, total of 8 electrons, complete the octet of the exterior atoms. And so in this case, we're going to go 1, 2, 3, 4, 5, 6. Okay, and then 1, 2, 3, 4, 5, 6, because that line, remember, represents 2 electrons. So this is 2, 4, 6, and then there's 8. Okay, so now we do this, and so now that's 2, 4, 6, 8, 10, 12, 14, 16, 18, and so that's 18 electrons we've used, and so now we're down to 2 electrons. And so the last step is determining, is a decision. Okay, now when it says to make a decision, that decision can be one of them, it could be step 4, it could be step 5, it could be both of them, or it could be neither of them. Okay, so that's the whole decision. There's actually 4 choices that you have to pick from. Okay, and so they are either make multiple bonds if there's not enough electrons around the around the central atom, or you have to take the extra electrons and put them around the central atom. So, in this case, we have 2 extra electrons, so we're going to put those 2 extra electrons here. And so now we also need to check to see if the central atom has its octet filled. So we have 2, 4, 6, 8. Yes, the phosphorus has a full octet, so that is good. We have 0 electrons left. We've used up all the valence electrons. Life is good. Okay, let's do another one of these. HCN. Okay, so this is hydrogen cyanide or cyanic acid. HCN is highly deadly. Okay, when you burn plastic, HCN kills you. It's just not good. That's a story in college about a nearly deadly almost fire. It was totally crazy. Anyways, so HCN, we have to count valence electrons. So get out your periodic table. Hydrogen has 1 electron, carbon 4, nitrogen 5. So 1, 4, 5, total 10 electrons. So we're going to put 10 electrons around this. No more, no less. That's what we have to deal with. So 10 electrons. Okay. So now we're going to do the skeleton structure. Now, this one is kind of interesting because the skeleton structure here is actually in the order that the molecule has the atoms. Okay, carbon is in the middle. If you follow the actual way to determine what goes in the middle, it's still the least electronegative. Carbon is the least electronegative element, and hydrogen can't be in the middle, and so nitrogen is more electronegative. So this is the actual skeleton structure, and we write it that way typically when there's 3 or more elements for these sorts of covalent compounds. So each of these have 2 electrons in them, so that's 2, 4, so we've used 4 electrons, and so we're down to 6 electrons. Now hydrogen is filled. Hydrogen is done because it can only have 2. Remember, its octet rule is that it just wants 2 electrons. And so now step 3 of that process is to put the just to fill the octet of the exterior atoms. So we're going to go 1, 2, 3, 4, 5, 6. So we've used up 6 more electrons. So now we're down to 0 electrons. That's it. We can't do any more with electrons. Okay? But now we go to our step 4 and step 5, which are the choices. The choices, are there other extra electrons? No. So if there's extra electrons, we don't have any extra electrons to put around the central atom, so that's not right. And does the central atom have 8 electrons around it? It does not. If we count, and I'll do that in red, we actually only have 4 electrons. There's 2, 4. There's only 4 electrons around the central. The octet rule says that we want to have 8. And so this is where we make multiple bonds. So what I'm going to do is I'm going to take these 2 electrons and I'm going to move them right into there. So now my structure looks like this, HC with a double bond in there, and now I've gotten rid of that. And notice by moving those electrons, I haven't changed the number of electrons. Okay, nor have I changed the number of electrons in nitrogen. Nitrogen still has 8 electrons in its valence. By putting those electrons in the middle, all I've done is added 2 electrons to the valence of carbon, and so carbon now has 6 electrons total, but that's not good enough. So we do that again. These 2 electrons here can move and get shared in the middle here. So H, single bond C, and now we have 3 pairs of electrons that are being shared between carbon and nitrogen. That's a triple bond, but that works. We didn't add any extra electrons because we don't have any electrons to add. It's very common for students to just kind of be like, well, blah, 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 blah. That's not the way to do it. We don't have the electrons to do it. We have to make double and triple bonds. So that is the example for making multiple bonds. Okay, so one more example here. Okay, the bromate ion. So now this is what we call a polyatomic ion. Polyatomic ions are ions that have two or more atoms in them. The bromate ion is BrO3 and it's 1 minus. Okay, so let me pull up the periodic table. Okay, over here. And now when we pull up the periodic table, bromine has 7, right? And oxygen has how many, right? 6. Okay. So we can go here, back to here, back to here, back to here. Okay, so bromine, there's 1, and so that's 7 electrons. Oxygen, there's 3 of them, so that's 6 times 3. And now this is a charge, so that means that 1 electron, that 1 electron is added to the overall. It's not added to a particular atom in here. It's added to the overall, this whole thing here. And remember, eventually we're going to put this in brackets because ions are brackets. So this 1 electron is added somewhere throughout this whole thing. So we have to add an extra electron. So this is 18 plus 7, 23, 25, sorry, plus 1 is 20, let's see, 18, 25, 26. So 26 electrons, okay? And so don't get thrown off by the fact that we have an ion up here, okay? It's okay. It's okay. Just follow the rules. So step 1, we counted our electrons. Now, out of bromine and oxygen, which one's the most electronegative? Which one's the least electronegative? Bromine, that's the central atom. And when we do this, that's usually listed first. So we put the oxygens around the outside. Okay. Now, by doing that, we've done 2, 4, 6. We've used up 6 electrons, so we're down to 20 electrons. Okay. Now we fill the exterior atoms. We fill its octet. Okay. And you get to the point where you draw so many electrons that it's just not fun anymore. Okay. Okay, so that's, by doing that, I've done 2, 4, 6, 8, 10, 12, 14, 16, 18. So I've used up 18 electrons. So now I'm down to 2 electrons. And now we make a decision. Those 2, the extra electrons go around the central atom. 1, 2. Does the central atom have 8 electrons, or 8? Does it have a full valence? 2, 4, 6, 8. Yes, it does. So everything's good. We don't have to make multiple bonds. Now there's one last thing that we have to do is we have to put this in brackets and put the extra 1 charge, put the 1 minus, indicating that we had to gain an electron. Okay? And that tells us, I mean, this is the only way that this thing can work is by gaining 1 electron. In order for the octets to be full, we can't gain 3 electrons. Then we would have kind of a weird situation here. We can't gain 2 electrons. Then we would have an odd number of electrons. While that can happen, we don't want it to. So I think that covers all the scenarios when we're drawing Lewis structures. The key to this is practice, practice, practice. So have fun and have a great day.